Welcome to drinktec 2025 and welcome to Krones. Sustainability Day here at our Krones Meet the Expert Forum. And when we talk about sustainability, we have to talk about water. That's for sure. One of the most valuable and increasingly limited resources we have on this planet. So it needs efficient treatment, it needs intelligent recycling and reuse, not only to contribute to sustainability, but at the same time to cut costs and also to comply with stricter regulations. And yes, I know getting there isn't easy. It's not a walk in the park. Nobody ever promised you that. It's a complex process. It needs smart planning and it needs smart equipment. Or best case scenario, a partner who is an expert in both. And this is exactly where Jörg Berger and Russ come into play. Jörg is a certified water sommelier and has over 25 years of experience in water treatment. And Michael is our expert for reusing and saving water, so he can help us optimize our water consumption. Let's figure out together how we can turn challenges into opportunities and give my experts a warm round of applause. Jörg Berger and Russ, it's so great to have you here.
Yeah.
Thank you for joining us today. So before we start, Jörg, why is it necessary, not to say crucial, especially for the beverage industry, to talk about water and act on it?
Yes, water is an essential part of each product. So up to 100% of a beverage is water. Yeah? And one main challenge is, as you said, the availability of water. And as you can see on this chart, there are a lot of regions in the world which have water stress. And therefore, the efficient use of the available water is essential. The goal is to have as much as possible water in the product and to minimize the water losses. One important key figure for that is the so-called water usage ratio. For example, breweries, best in class, has a water usage ratio of 1 to 3, means 3 liters of water needed for producing 1 liter of beer. Usual is 1.4 up to 1.5.
Wow.
So in some cases, in addition, the extension of an existing beverage production site is only possible if you reuse water, because no more water is available. And for this then, also to improve the water usage ratio, one important puzzle is the water treatment itself.
Okay, and to get this clear, when you say availability of water, you do not only talk about availability itself, but the available quality, right?
Exactly. Also the quality of the available water is in addition an aspect of the global water crisis and has a significant influence on the required treatment and its efficiency. Besides the scarcity topics around the world, also pollution is more and more a challenge. So we distinguish between naturally occurring impurities, depending on the soil, the rocks, the water has passed through its way to the ground, and the man-made impurities. For the natural impurities, for example, this is iron manganese or arsenic or microorganism. Yeah? And as you can see on this chart, there is an example of the arsenic distribution globally. And you can see some hot spots in Argentina, India, Bangladesh and Mexico. Yeah? For the anthropogenic pollutions, there are examples like pharmaceuticals, eternity chemicals like PFAS, or even the pesticides. And an example for the pesticides you can see on this chart. Yeah, worldwide there are a lot of regions where we're facing a lot of pesticides in the water.
So we need to do something about it, that's for sure. So how do we get rid of these impurities and also of the pollutions?
Yeah, so all these impurities are unwanted in the water used for drinking or for beverage production.
Sure.
And therefore we have to go with water treatment. And to show you an example, there are different ways to get the required water qualities for the beverage production. Always sometimes starting with a raw water tank, which is also used for, by adding chlorine for disinfection purposes, followed by a filtration unit. This filtration unit could be a media filter, like a sand filter, to get rid of the formerly mentioned iron, for example, or a carbon filter to reduce the PFAS or the pesticides. Yeah? An alternative filtration step could be an ultrafiltration. An ultrafiltration has membranes in, and the membranes has a pore size of 0.02 micrometer.
Okay.
Can you imagine what is 0.02 micrometers?
Not really, right?
Okay, so to illustrate this, you can compare it, the pore size compared of the membrane pore to the bacteria is, the membrane pore is a shot glass, and the bacteria is a beer mug. This is just half one, but you know already the beer mugs from the Oktoberfest. They are more bigger. Yeah, so it's a big size difference, and due to that, it's possible to remove bacteria and viruses with a ultrafiltration membrane.
All right, a good example. Like it.
So, and this then, after the filtration, we have another step followed for the removal of this dissolved solids like salts, to remove the TDS and to focus on the alkalinity. Both of these parameters are important for the production of CSDs or of beer.
Why?
Yeah. Did you know that here in Munich, with the available tap water in Munich, it's only possible without a treatment to brew dark beers?
Dark beer in Munich.
Yes.
Of all places. The city world famous for Helles and Weiss beer. You would have to rewrite history. This is insane.
You see how important water treatment is, not only due to the pollution.
Now I understand it.
So, and if we go further with this path, with this blue path, yellow path, you see the treatment which can be used for producing brewing water. And this is exactly what we have established here in Munich at the Paulaner Brewery.
Okay.
Yeah, but not only for brewing water we need water treatment. A lot of bottled water productions also requires water treatment, and this is another example. And there we have additional units, for example, like a mineral dosing to remineralize the purified water, and to have an ozone adding system to secure the filling process.
Okay, so there's a lot of options to choose from. So when you get on board with your customer, you select the right water treatment concept, the individual design for your customers, and what's next?
Yeah, we have also focused to increase this water usage ratio by our hydronomic system, which comes with fully automatic water production and CIP processes for cleaning programs. Also, the control and recording of process parameters makes it possible to optimize the water usage ratio by, for example, flushing the media filter when it's required and not when it's just needed. And we have also designed our hydronomic system to be fully hot water sanitizable. This has the advantage that we minimize the usage of chemicals for cleaning, which then also avoid the contamination of the cleaning water.
Wow.
And in addition, we also have the possibility of providing water reuse in the water treatment itself.
Okay, now you lost me. How can we how can we picture that in practice?
Yeah, let me come back to the example from before. There is our process, and in this process it's possible, for example, to collect the water from flushing the media filter. We can collect the water from the ultrafiltration back flushing, as well as the concentrate of the RO units. And with this water we can use several treatment steps depending on the raw water quality, depending on the water treatment concept itself, and can treat the water in a way that we can use it for utilities, means boiler feed water or for cooling towers, or send it back to the raw water tank to use it again for production. Yeah, that's what we can do inside the water treatment itself. But there is not only the internal reuse of water in the water treatment itself, there is also solutions available at Krones to focus on the whole production plant. But this is Michael's part.
Michael's part. Okay, first of all, thank you so much. This was highly interesting, and I learned again so much, so thank you for that already.
Thank you.
Well, Michael, how can we reuse as much water as possible?
Yeah. First, thanks for the introduction. And Jörg, thank you. My grandmother always said, don't mess with a water sommelier. And I would like to give you an idea today how to reuse water in the process again. So, starting with a slide, we at Krones, we developed two systems. One system for the plastic recycling, up to 80% water reusable is possible. And today I would like to show you the system for the beverage industry, and there we can use up to 70% of water again and reuse it in the production as a processed water. So starting on the left-hand side, you see the production. The wastewater is coming and we are going over a drum screen. Yeah, the drum screen is a screen to remove some spent grains, for example, from a brewery application. And then we are going to a storage tank, equalization tank, and give there some acid and base to neutralize the water and to adjust the pH value. Then we have the anaerobic stage, that's the heart of the system. And there is also biogas produced, which you can use again as a substitution for natural gas, for example. Third stage is the aerobic stage. There is the sludge also dewatered. Then there comes the reverse osmosis, the disinfection, and then as a processed water in the production. So I will go a little bit more in detail in the next slide. There you can see the system in a drawing. And we're starting first with the drum screen, then coming with the calamity tank, the equalization tank, and also the chemical station to dose the acid and the base to neutralize the water for the next step, and that's the heart of the system. It's the so-called DAX reactor. We developed it with a supplier of us together with the Kana, and within this reactor we are treating the wastewater anaerobic, so without oxygen, and there the biogas is also produced. So if you are producing biogas, you need also some systems for calamity. For example, there is a biogas flare in case that you don't need or use the biogas. And there is also installation for treating the biogas, so it has to be dewatered. The sulfur has to be removed, so you have an activated carbon filter and also then a dryer, a biogas dryer. And in some region, it could be that you need a biofilter that you remove the smell from the air around of the plant. So the next step then is the so-called MBR aeration tank, MBR reactor. There is also submerged ultrafiltration inside, and this is the second step. After this step, you can bring the water out to the municipality, wastewater treatment, for example, or release it to a river. So at this step also the sludge is put it out of the system, is dewatered, and then has to bring out of the system. And then, Jörg, we are coming to your part again, back again to the roots where we are coming from. Krones is the reverse osmosis, and within the reverse osmosis we treat the water on the last step. There is then also the disinfection, and then we can use the water again for SIP, for example, or cooling towers, or heating vessels, for example. So this is the way we retreat the water back again and use in the process.
Wow. Okay, thank you for that theoretical explanation. So you
Yes.
also have some practical examples.
Yes, I have also some practicals with me. And there on the left-hand side you see a cider production. And yeah, it's also an application where you can reuse water. And on the right-hand side you see the Carmelitan Brewery. And yeah, I would like to invite you when you're coming to Neutraubling. It's next to our headquarters, a smaller brewery in my hometown, so we can go there and see this application on site. You can talk with our customer, he's very satisfied with this solution, and we can have a look there really on site, and I can show you each part in detail.
That is a unique opportunity to really get an exclusive glimpse behind the scenes. So obviously your customer is very happy with you that he invites everybody in to show off with this amazing plan.
I asked before.
Awesome, awesome. Is this only possible for greenfield, or is it also a retrofit schedule here for brownfield plants? And if so, how would that work?
No, it's also possible for brownfield. And on the next slide, I can show you on the left-hand side, it's a brewery in the Blackwoods. And there are some concrete tanks. It's a huge space demand. And when you look on the right side, there is the DAX reactor I just shown before, and the MBR. And we can have with this system a much smaller footprint. So this is also one of the advantages of this system.
Imagine a brewery in the center of an old town. No more space.
Of course, in a city applications.
Exactly.
And
many old breweries, for example, are in that area. But that is amazing. So, but I do know that you never rest on your laurels.
Yeah, but one slide. Maybe let's just sum up.
Sure.
We have a comprehensive consulting, like Norbert is here, my colleague. He just presented our consulting group. So we don't do just wastewater, we're also doing energy efficiency. So as I told you, up to 70% water reuse is possible. It's a tried and tested technology, also patent technology, high hygienic standard. Jörg?
Yeah.
HydroCircle system and a reduced space demand. And also what's to be mentioned is the high methane content, because normally in biogas or in farming applications you have a methane content of around about 65%, and here with our systems we are reaching methane contents more than 80 up to 90%.
Incredible numbers.
Yeah.
Thank you so much. First of all, an applause for these impressive numbers and the good explanation. But as I said before, I know that Krones never rests on its laurels. You always have your ear to the ground. You always try to become even better for your customers, together with your customers, growing together, learning from each other, exchanging ideas. So is there anything new in a pipeline, any new projects you can already share, want to share, not top secret anymore?
Yeah, I would like to show something.
Okay.
Thanks. We are going further. The beat goes on, I would say. And we are working on the solutions beyond tomorrow. So we just jumped in a project with the Technical University of Munich, Regensburg and Nuremberg. And there are plenty of our customers within this project. And we are thinking about solutions to treat the water within the process, not do the big bang at the end and put all the wastewater together. So we are looking for single solutions in the production, and that's what the project forces for the next 2.5 years.
Many, many little steps eventually lead us to our ultimate goal.
Yeah.
It's amazing. Thank you so much, Jörg, Michael, for the great introduction of your systems. And I think a trade show is always, of course, a great opportunity to exchange ideas, to mix, mingle, network. So where can we find you right after this presentation?
Jörg and me, we will be there just beside the Steinecker. There is the tap, and you will find us just beside the tap. So maybe we could have a beer together and make the pleasure with the work and bring it together. So hope to see you soon, and we are just a few meters above there.
And they also have fantastic alcohol-free beer in case anybody still needs to drive. So there's plenty of
already. Alcohol-free beer is sold out.
Amazing. Thank you so much. Once again, your applause, and thank you for joining us. Let's shape the future together. We only have this one.